Well, how are you? Boys and girls, hey, this is Mr. James. Time to learn a little bit of science here. Thanks for watching. Boy, I miss you guys. Typically I'm in a school every day doing a science program about the wonderful science of weather called meteorology. Yeah, and I really miss it, but that's okay. We can gather together and do it this way. This will work just fine. Hope your week has been doing very efficiently. We had a busy week in the weather world, but first off, what I want to do is start with our planet. I like to do this every week. This is what we look like this morning from 22,500 miles over the Earth's equator. I mean, we're looking good, but wow, we had a big weather event since we talked last Thursday. For those of you living in the southern United States, we had a lot of tornado activity back on Easter Sunday. Wow. This tweet is from the National Weather Service, and they're working hard to try and survey all of these tornadoes. And so far, they've identified 105 tornadoes from Sunday night, and early Monday morning. And they were in a bunch of states. In fact, I'll show you a map of what this looked like. This is all the way from Texas to North Carolina. And my state, Alabama, had 21 tornadoes. But the most violent tornadoes were down over South Mississippi. This is one of them. In fact, one of those tornadoes was rated EF4. And if you remember, our tornado scale is 0 to 5, the EF scale, and this was rated EF4. That's a very large tornado. In fact, that tornado at points was over 2 miles wide. Pretty crazy stuff. But today, and by the way, we're going to answer some questions and we'll talk about different things, but the focus today, it's on winter. Winter storms, snow. If you watch my first segment, I think you know that my favorite season of the 4 seasons is winter. And I'm a little sad because, well, it's almost over. Now, the truth is we're still getting snow in places, but it's almost over. But yeah, I don't know why, but I really like winter, and I like the kind of weather that it brings. This was a good snow, by the way. This was back in December of 2017. They played a state championship football game that day. Plenty of good seats were available. That was in Tuscaloosa, Alabama at Bryant-Denny Stadium. But this was a good snow because with this snow, we had 5, 6, 7 inches, but we had power. The roads weren't that bad. The roads were just wet. It didn't last long. It was forecast well. People were home. But and this was before Christmas. And by the way, the pictures that make it on television always say that for some unknown reason. And by the way, this was yesterday, April 15th in Ohio. It was snowing. Cities like Chicago, Illinois had snow yesterday morning. They had a lot of traffic accidents because of that. And some of that snow is shifted into the northeast United States this morning. And a new snowstorm is forming back in the west. This picture was sent to me about 30 minutes ago. This is Denver, Colorado. Right now, that's what it looks like. So yeah, sometimes winter can hold on even though it's been spring for a while. By the way, I got to show you something. In fact, I showed you this the first time I did one of these, but maybe you missed it. I want to show you what it looks like in a television weather office when it starts to snow. I don't show this to a lot of people, but I'll show this to you because I like you guys. When the first flake starts to fall, this is what it looks like in my weather operation. Right here. Ah! I'm not going to say which one of these guys I happen to be, but let's talk about snow. We'll talk about how snow forms, and we'll talk about the different kinds of winter precipitation, sleet, grapple. Do you know what that is? But first off, I want to talk about the biggest snowstorm I've experienced. Now, think about you. Think about your life, and maybe you're 5 or 10 or 12, or maybe you're some old guy like me. What's the biggest snowstorm that you've experienced? Well, mine was a long, long time ago in the year 1993. And most people call it the blizzard of 1993 because it was so windy. The winds gusted to hurricane force while snow was falling. This is the satellite view of that big storm. Look at this thing winding up in the Gulf of Mexico. Severe storms in Florida, heavy snow for the eastern part of the United States, and it was very remarkable. Now, one of the cool things about satellite photographs, with visible satellite pictures, you can see snow on the ground. Look carefully, all the white in Alabama, Tennessee, Georgia, the Carolinas, Northeast, that's all snow on the ground. And you know it's a lot of snow, and you can see it from 22,000 miles in space. But during that event, which, by the way, was in the middle of March 1993, when the flowers were starting to bloom, parts of the deep south had over 1 foot of snow. Now, in this picture, I'm not so sure if I'm more impressed with the snow or the gas prices. How about $1.07 a gallon? Or maybe that payphone, and most of you boys and girls have no idea what that is. But yeah, Birmingham, Alabama's official total with this was 13 inches, but some places had over 2 feet. And the drifts, the snow drifts, were over 4 or 5 feet. In fact, my car at the TV station was just totally covered by a drift of snow. And I tried to dig that thing out, and after about an hour, I just gave up. So we just decided to stay in place. But, we didn't have phones back in 1993. The camera phones, everybody's got a camera phone now. So back in 1993, we had to have camcorders, which you've probably never seen before, but this is some old video from a camcorder from that big snow day on the eastern side of Alabama. But this was one for the ages. We call these kind of snow days generational because they tend to happen about once every 40 years. But that was really remarkable. The bad part about that, though, some people had no power for weeks. And we had a lot of accidents, and it was a pretty tough situation. But again, that was the great blizzard of 1993. That was my biggest snow in my life. But let's talk about water before we talk about snow. I like to talk about water. Hey, if you dump a bucket of water on me, I'm going to get wet. If I dump a bucket of water on you, you're going to get wet, and your mom will get really mad at Mr. James. Yes. So water can be a liquid. I mean, come on, you can drink water. You know that. But wait a minute. Water can also be a solid. What do you call water when it's solid? Does anybody know? Come on. It's cold. It's ice. Yeah, you know that. So water can be a liquid, water can be a solid, and water can also be a gas. Yeah, there's always water in the air, water vapor. And so let's talk about the water cycle. I think you know this. I think most kids are learning this in kindergarten now. But that's the cycle. Let's start with evaporation. All right, so we have water in oceans and lakes and rivers and in the soil, and that liquid turns to water vapor, turns to gas. We have transpiration. Water from plants turns to gas. Then on the way up, we have condensation. The gas cools, turns to liquid, water, or ice. And then we have what? Yes, precipitation. And that's the main thing we're going to talk about today, the different kinds of precipitation. One thing I've learned, even older adults really don't understand certain types of precipitation. So let's do that today. Now, easiest one is what? Rain. Come on. Everybody knows what rain is. That's awfully easy. But what about hail? I think a lot of people don't really know the difference between hail and sleet. Okay, hail does not have anything to do with a winter storm. Hail has everything to do with a thunderstorm. Okay, here's a big storm, and man, it's windy. And look really carefully down there in the ground. What do you see? Yeah, little balls of ice, and that's hail. And hail can happen on a day when it's 85 degrees at the surface, when it's warm. Hail can happen in summertime. Why? Well, the hail forms way up in the top of a big thunderstorm. Up in the top of a storm, even in July and August, the hottest part of the summer, it's way below freezing. And if that big updraft is strong enough, some of the water is taken up into the sub-freezing region, and that water can turn into ice. And if the ice gets big enough, it can make it all the way back down to the surface before it melts. And again, this is called hail. So understand, as we talk about winter storms today, this is not a winter storm. This is a thunderstorm that produces hail. And this can happen any time of the year. And hail, if it gets really big, is not that good. Imagine hail that large falling on your house or your car. This can cause a lot of damage. And you know this. We taught you this the first week. Whenever we have large hail like that in a storm, we call the storm what? Yes, severe. I think you know that. So remember, hail is not what you're going to see in winter storms. That's something else that we'll talk about. In fact, let's just talk about that right now. Sometimes you'll see little ice pellets falling on a cold, cold, wintry day. That's not hail. That is sleet. And here's a big one. I'll tell you this. Now, these two types of precipitation come with winter storms. Sleet and freezing rain. Some people think they're the same thing. Some people hear, well, we've got freezing rain in the forecast. That means the raindrops freeze into little ice pellets and they come all the way down to the ground. Nope, 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 no. That's sleet, little ice pellets. Freezing rain, it's liquid. If you walk outside, it's raining, you get wet. But the difference is that temperatures at the surface are colder than 32 Fahrenheit or 0 Celsius, which means after the rain comes down, the freezing rains, then it turns into ice and it coats everything. Now, sleet looks a little bit like this. And typically, sleet doesn't cause too many problems. If we get sleet, it might make a road a little icy, but generally speaking, no. In fact, that's the precipitation with winter storms that has the least impact. It's sleet. But freezing rain is nasty stuff. Oh boy, I say nasty. It's actually beautiful, but try and imagine driving in this stuff or dealing with it. It's tough. Again, this is rain that falls in liquid form. It's below 32 Fahrenheit, and it coats everything with ice. Every exposed object, like trees and power lines and roads. And the trees can become so heavy, they can snap and break. And have you ever tried to drive on ice? This is some video from an ice storm we had here in my market in Birmingham, Alabama a few years ago. And this is a major interstate highway. That's Interstate 65. And boy, this is not good. That is a solid slab of ice. And people were having a really hard time. They would stop. They couldn't get started. People tried to stop, and they kept sliding. This is really dangerous stuff, but this is what freezing rain can do. That's not snow. That's ice and freezing rain. So out of all the different types of winter weather, I'd say that's my least favorite. And understand, if we get a lot of freezing rain for a long time, that's called an ice storm. So an ice storm is a long period of freezing rain. And that is a big mess. That just makes my eye twitch thinking about that. So that's sleet and freezing rain. Now, let's talk about two other types of winter storm precipitation. Graupel and snow. And I know what you're thinking. I know what snow is. What is that graupel thing? I've never heard of that. Well, sometimes it happens. So let me ask you this. Have you ever had Dippin' Dots before? I bet you have. Graupel is more like Dippin' Dots, okay? So sleet, those are little ice pellets. But graupel, it's like really soft. You can almost squeeze it and it moves. And that occasionally will happen. And graupel doesn't happen a lot, doesn't typically cause a lot of problems. But I think everybody knows about snow. Yeah. And what I want to do is show a little video from the National Science Foundation. Our friends there, they do a great job. They fund researchers that learn so much that help us. We're practitioners. But here's a video. It's basically about some equipment they have called the PWI, a special weather imager to take images of snowflakes. But this is about snow and how snow forms. I'd love to watch this. Check it out.
Snowflakes have brief but complicated lives. They start when a super cold water droplet freezes around a speck of dust. This process alone results in Wilson Bentley's famous six-sided crystal. But it's difficult to discover one of these on the ground, because as a snowflake falls, it collides and freezes with other water droplets, a process known as riming, resulting in a little ice pellet called a graupel, the hard-packing snow. If a snowflake manages to dodge these water droplets, it will likely later collide with other snowflakes to form something entirely different. An aggregate, the light fluffy snow. So the PWI photographs falling precipitation and then classifies every single photo. Aggregate, graupel, sleet, ice, rain. Each type of precipitation affects road conditions differently. Projecting these, especially around the freezing point, is a current problem. But with the PWI's data, local transportation departments could issue better weather warnings, with the potential to save lives. The PWI also captures nature in its purest form. Common among snowflake photographers, Bentley hand-selected the most attractive snowflakes to photograph and rejected those less photogenic. What Bentley and many others did was spark the public's fascination and curiosity about snowflakes, leading to the PWI's modern-day answer to how to capture a snowflake.
And that PWI is a special camera that can capture snowflakes and to study them, which is just like awesome. And by the way, you can have good snow and you can have bad snow. I want to show you a good snow day. This is some amazing photography. By the way, some of the videos I show, I love that. The opening video that you see every week, that's from Mike Olbinski. Go follow him on YouTube or Vimeo. His work is great. This is from Kevin Henderson, and he has a business called Skybama, and they fly drones and weather, and Kevin does a great job too. This was a good snow. Why is it a good snow? Well, again, it's like the one I showed you before Christmas back in 2017. People were home, and we had power, and the roads were kind of tricky in this one, but everybody had a lot of fun. And folks were just great. I mean, I love rocking a drone in a snowstorm. That's a good example of a good snowstorm. But sometimes you can have bad snow. Uh-oh. So this happened in January of 2014. And look what happened. All these people getting stuck. This was called Snowmageddon. And this is from Kevin as well. He flew his drone in this. And here's the deal. Let me just talk about Snowmageddon. We thought it was going to snow a little bit. And it did, but we didn't think the roads would be bad. And woo, we were so wrong. The roads were just horrible. Here's what happened. When the snow came down, the snow melted because the ground was warm. But the air was so cold, the air was 18 degrees Fahrenheit, that snow melt turned into ice. We had what we call a flash freeze, and within no time at all, these roads were coated with ice like an ice storm. Most of the time when it snows where I am, it's about 30 to 40 degrees. And we've had no experience with this. Boy, we've had some experience now. But everybody tried to go home at once. And a lot of people got stranded. Some people were down there for hours and hours and hours. And they were running out of gas. They were getting cold and hungry. You know what they're doing on the side of the road down there? They're burning anything they could out of their cars just to stay warm. This was a major mess, and we caused it. And this is a reminder. There's a lot of things we don't know, and there's a lot of things we can't do. I need some of you, boys and girls, to get into our science and help us. The science of weather, again, is called meteorology, and I promise, by the time you get to college, there'll be a lot to learn. As I get older, I realize the more things that we don't know. So that was a big mess and a bad kind of snow. But this is kind of a cool diagram. This shows all of our major precipitation types. So we all know about rain. That's when the whole column, it's good and warm, and it's all above freezing, and it's just raining. Freezing rain is when the cold air is really shallow and it's real close to the surface. But if you go up 3, 4, 5,000 feet, it's warm. It's warm up there. So everything is just all rain, and it doesn't have time to freeze or turn into snow by the time it reaches the surface, but it's below freezing down at the surface, and that's when everything gets coated with ice. And I'm telling you, boys and girls, that is my least favorite kind of winter weather, and it's just bad. And a big ice storm, which is caused by freezing rain, you can have power outages for weeks. Trees can come down. It's just not good. Now, sleet, those are little ice pellets. That's when there's not much warm air up there. It's mostly cold. And then snow on the right, yeah, that's when the whole column is cold, below freezing, and it's just all snow. So winter weather can happen as late as May in some parts of the country. For our friends out in the mountains, Colorado and Wyoming, they can see snow in May, and they typically start seeing snow again in September. But down here where I am in the deep south, it doesn't snow that much. And that's the reason that whenever we have snow, it looks like this in the weather office. All right, got to do some questions here. I got so many good questions. Got time for a few of them. Let's roll one of them.
Hey, James Spann. This is Addison and Bryant from Jacksonville, Alabama, Kitty Stone School. I have a question for you. Why are the two types of snow, wet and dry?
Ooh, that's a good question. Yes, there are different kinds of snow. And by the way, you know this, every snowflake is different. Just like everybody watching this is different, every snowflake is different, but they're kind of categorized into that wet and dry category. Here's the deal. The dry snow, that's when it's really cold. I mean really cold, all the way from the surface on up to the top of the atmosphere. It's really cold. And it typically is dry, and it's often called powder if you like to snow ski. Some of you do, some of you haven't tried that, but boy, that's a lot of fun. They love fresh powder. That's dry snow. That's on the left. Now, over there on the right, that's the wet snow, and that's when it's not as cold above the surface of the earth. You might have a few layers where it's maybe a little above freezing, and you get a whole lot more liquid involved in that, and it's heavy and it's wet. I like the dry snow a little better, but they both have good things and bad things. The bad thing about the dry snow, it's really hard to make a snowman. If you want a good snowman, you want that wet snow. But the bad thing about the wet snow, that can really get on trees and leaves and branches and cause them to break and fall, and the power goes out. But there's a clear difference in those two types of snowflakes. Let's roll another question.
Hi, Mr. Stan. Why does the tornado spin clockwise and the hurricane spin counterclockwise? Bye.
Bye. Ooh. Well, yeah, some hurricanes spin clockwise, some spin counterclockwise, some tornadoes spin clockwise, some counterclockwise. But this is the general rule. It all depends on where on the planet they're happening. In the northern hemisphere, north of the equator, they all go, and this is most tornadoes, not necessarily all, but most of them will go counterclockwise, and hurricanes go counterclockwise. Down in the southern hemisphere, below the Earth's equator, they go clockwise. They go in the opposite direction. Kind of works the same thing when you flush the toilet, you know? I mean, but it's the Coriolis force, because the fact that the Earth is rotating on an axis. So they all do have some spin, but they typically spin in the same direction in the northern hemisphere, and then they change in the southern hemisphere. All right, so let's see. This is a couple of guys wanting to know, how can we protect our homes against severe winds? And they thought this was fitting after the recent severe weather we've had. Well, the real way to do that is when they build a house. That's the key, is how houses are built. Some houses are built really well, and some are a little iffy. A lot of it has to do with the anchor bolts, the bolts that hold a house down onto the slab or the foundation. Let me show you some wind tunnel video. I think I've shown you this before. That house over there on the left, it's not anchored very well, and that can happen. But the house over there on the right, when you got good anchor bolts, it's pretty much going to stay in place. Now, this house has good anchor bolts, but in a strong tornado, the roof is going to go off. This is why we always want people down there in the lowest floor. The lowest floor always gives you great protection. But the key to making a house safe, it's just when they're built, okay? But you can't change that. You're living in it now. So this is all you need to know. When there's a severe storm and then a tornado, you want to be where? Downstairs. Never up, but down. You don't have to be underground. A lot of people don't have basements. That's fine. Just be on the first floor, not in a big room, but a small room. Near the center of the house, as many walls between you and the tornado as you can, and away from windows, and you'll be fine. And we want you wearing a helmet, okay? All right, this is from a teacher that is asking this question from students. Why are tornadoes so hard to predict? Well, the short answer is the fact that they're tiny. I mean, they're like really small. Even the big tornadoes are like really, really small. But let me give you a good example, okay? This is what's going on right now. This is the severe weather outlook for Sunday, April 19th. This Sunday, not last Sunday. We had that big bad weather day last Sunday. This is for this Sunday, April 19th. And so we believe that conditions will be favorable for tornadoes and severe storms in that yellow area. Now, that's a big, big area. The truth is we have no earthly idea where the individual tornadoes will form right now, 4 days in advance. We just don't know. But we know that conditions are favorable in that big zone from eastern Texas over to South Carolina. And the probabilities are really higher over the southern part of Mississippi, Alabama, Louisiana. But even there, that's a big, big area. So we just don't know. Now, once we get closer to the event, these are issued. This is called a tornado watch. Now, this is one issued this past Sunday, and we might see some this Sunday. But notice it's a pretty big area, and even then, we don't exactly know where the tornadoes are going to touch down because they are so tiny. They come from individual thunderstorms, and we just don't know where they're going to develop. But in that zone, that's where everything seems to be lining up for tornadoes. And then once we get within, 40, 30 minutes, then these are issued. And this is how we do know where they are. This is called a tornado warning. And this is when somebody has reported a tornado, we see a tornado on radar, or we know they're happening. So, yes, we can tell you that tornadoes are coming, but we can't do it in a specific spot 4 days in advance or 6 hours in advance. Most of the lead time, it's 10, 20, or 30 minutes. And in some cases, you don't get any lead time. Some of those small tornadoes can literally be under the radar. Speaking of radar, let me give you a radar test. I want to be sure that you can spot tornadoes, okay? So we've talked about this several times. So on the left, that's the rain. On the right, that's the wind. And this is a pretty bad one. So let's see if in both of those pictures you can find the tornado. And this is what we use. And boy, radar was so helpful this past Sunday with all those tornadoes across the southern states. They did a very good job. So I'll give you a second here. So just take a good look. And I want you to pick out a spot on the left and on the right. On the left, that's rain. Okay, that's called reflectivity. On the right, that's wind. That's velocity. And there is a really easy to find tornado. And it's the same tornado, by the way. Those radar pictures were captured at the same time, the same place, same storm, just different products. Rain on the left, wind on the right. So let's see if you passed my radar exam. There you go. We got a hook echo in that rain. And at the end of the hook, there's a little spot that we call a debris ball. That's objects being taken up from the ground and carried way up 10, 20,000 feet sometimes. And over there on the right, you can see those intense colors. And that's where the tornado is located. And that's a really bad tornado. That was a rough one. But you're good. You got this. I mean, you got this. That's the great thing about this. Let me tell you what, I've learned this. A lot of times you kids lead the way. You really help us because you're teaching your parents a lot of things about how to be prepared for weather. And let me just say this again. I don't want any boy or girl afraid of storms. Storms are good. We've talked about this before. We need them. It is an integral part of the water cycle. For a lot of you, where you live, most of your precipitation comes from storms. If we don't have them, we don't have enough water. And everybody has to have water to live. The creeks can dry up. The rivers can dry up. The lakes can dry up. And that's where we pull the water and we purify it and it goes to your house. So I am thankful we have storms, and hardly any of them will produce a tornado, even on a bad day like Easter Sunday. For most of you, you didn't have any problem. Now, some of you did, but for most people, they didn't. And by the way, I want to teach you one more thing. Every day, our friends at the Storm Prediction Center issue a severe weather outlook. And I want you to be sure you know what those colors mean and the numbers. So we have 5 levels. Level 1 is green, that dark green, called marginal. And that means there might be a bad storm, but probably not. That's kind of the lowest end threat. Where you see the yellow, that number 2, that slight, that's where a lot of our severe weather happens. That's kind of the standard risk. But the really bad days, you start to see the orange and the red and that bright pink purple color. 3 is enhanced, 4 is moderate, and 5 is high. You don't see many high-risk days. You might see 1 or 2 a year, and that's about it. But if you see a 3 or a 4, you really need to pay attention. For example, last Easter Sunday, the risk was 4 out of 5 for a lot of places. And we are in the middle of the tornado season for the southern United States. It begins to shift up toward the Great Plains in May and June, but it's just a time of the year where this stuff happens. And the one thing I've learned about a lot of kids, once they learn what we're teaching here, instead of being afraid, they're fascinated. And guess what? A lot of them turn out to be the most brilliant scientists in meteorology. In fact, a lot of people working in my field today used to be afraid of weather. And then they started to learn these things. And they wanted to learn more and more. And they wound up going to college and majoring in meteorology. So that's something to think about. You can do that. But listen, thank you guys for watching and listening today. Love talking about the snow and the winter storms. Hope you learned a lot. We'll be back next week. And again, your parents can submit questions if they want. We'll try and answer some more next week. And I will say next week we might have some rough weather on Thursday, the 23rd. And if by chance we do, we'll probably postpone it a day or two after that. Because one thing about me, when the weather starts getting bad, I have to be in the office and take care of business. But thank you guys for watching. It's always great having you. And if this is the first time you've watched one of these, I think this is the 5th one I've done. And they're all up on YouTube. We're doing this live on Facebook, but we archive these on YouTube. You can go back and watch all of them. And it's a pretty cool science lesson about the science of meteorology. So thank you guys for watching. Y'all have a great day, and we'll talk to you next week.